Okay, last take, final take. Let's make the curtains work. Yes, you see the black curtain behind us, and this thing in front of us you don't see. It's called a light board. Okay, we're going to use the light board today. All right, to explain to you something about current. Okay, something very basic, current. First of all, the symbol for a battery, right, or a cell. I mean, whatever you call it.
I suppose we could label one a plus.
Yes.
And the other
yes.
the minus.
The longer one is usually the plus, right? That's a convention.
Yeah.
Shorter one is the minus. Let's just hook it up to a resistor. We can draw it as a rectangular box. Put an R there just to be clear. And so we have a closed circuit. Closed circuit means we have a
current flow, I guess.
Current
from
flow.
The positive side
Okay.
to the negative side.
Sure. Let's draw that in.
Okay.
Okay. I. Okay. Yes. I plus and I minus. It's true. I didn't realize they could be different. Can they be different?
Well.
Current. Resistor. Current. Battery.
Yeah. So I think that from the positive side to the resistor and from the resistor to the positive side, there may be differences between currents.
You mean I plus? If I get your. It seems to me clearly I plus must be bigger than I minus, right?
Yeah, because there's a resistor there. I mean, our
Sure.
teachers usually tell us that they're equal.
Equal. Yeah.
Yeah, but it seems strange, doesn't it? Like there's a resistor here.
Yeah.
It seems to be that this will slow down the current after the charges pass through.
Right. So yeah, I plus greater than I minus. Is there any problem with our logic? Let's see. What does current mean? Current is the flow of
electrons or charges.
Charges, right? Right in a metal. I suppose it's a wire, right? Copper wire.
Oh wait, but if it's an electron, it will flow in the opposite direction.
Right. Because electrons are negatively charged.
Yeah.
Yes, negatively charged. So, say you have an electron. I mean, just draw like an electron here. It would go from the minus to the plus, right?
Yeah.
So the electrons will be moving like in this direction. So you like sort of move here, right round the circuit, reach the resistor.
And then it should slow down.
Slow down. So then slowly make its way back. To the battery.
Yep, where it gets more energy and then
speed up again.
Yeah.
Right.
That makes sense, right? But
right.
wait. Does that mean that the current here is larger than the current here?
You mean if you think about electrons, then you have I plus actually less than I minus.
Yeah, that makes sense, right?
Huh.
So,
Well, they can't both be, right?
Yeah.
Okay, right, but we do know it's electrons, right?
Yeah, but I mean, if it's a positive charge, then I suppose the logic's reversed. So but for electrons, yeah, I think this must be it.
We'll
work with that one.
Okay. Well, but let's see. They move so fast here, and over here they get, I don't know, squeezed.
Yeah, I guess that means they'll kind of build up here because
yes. A lot more electrons here, right? Stuck. What's blocking them? Why can't they move faster? I mean, if you get so jammed as an electron, well, you're a charged particle, right?
Yeah.
You repel your neighbors, right?
Yeah,
I mean, like charges
then
repel.
I guess they will move backwards.
Or they spread out a bit more. This side can afford to squeeze a bit. Right.
Yeah.
Hey, maybe our physics teachers are right.
Well,
I plus equals I minus. Isn't that a solution to all our problems?
I guess, because that would mean that the charges kind of move at the same rate throughout the thing. And there would be no accumulation of charges on either side.
Perfect. Then we can just write, I. Okay, but what's the current through the resistor?
I suppose it will have to be I too because...
So just I everywhere. Through the battery?
Yeah.
Same.
But what does the resistor do? I mean, if this logic is correct...
Right. It doesn't slow it down, right?
The resistor doesn't seem to slow it down. So what does the resistor do?
Okay, wait, we've asked the question, what does the resistor do? Then I guess we have to imagine Well, but if we didn't have a resistor?
Okay, let's take the resistor away.
Okay, okay, no resistor, all right. Erase it from the board, all right.
Now we have an open circuit.
Open circuit, so current?
No current.
No current, no
because
current.
It's open circuit.
Sure.
So let's close it with a wire.
Wire?
Resistor.
Well, no, can't.
Oh.
Why do you do that?
That will cause a big problem.
Oh, that's no
because
good.
There'll be a very high current.
Yeah,
And then,
short circuit,
woo,
right? Short
there'll be a
circuit.
fire.
Yeah, not good, not good.
Yeah. So.
But well, we're just thinking about
Okay,
things.
so
right?
let's
Okay.
put the resistor back and see
So
what happens.
okay, so the resistor. Well, I guess the resistor limits the current, doesn't it?
Yeah. So
You know,
let's-
if you don't have a resistor, you have like, too much current. You have a resistor, you can control the amount of current, right?
So with a resistor, the current drops slightly compared to if there was no resistor.
Okay, okay. You have a bigger
And
resistor?
If you have a bigger resistor, then
Higher
the
resistance?
current drops some more.
Okay, so the resistance controls, I guess, how the balance of all these currents.
So I guess the resistor doesn't just slow the current down after it, but
No,
throughout the entire
the whole circuit, right?
Ah, that makes sense.
So the resistance, I mean, you have to think of the whole circuit. I mean, it's a
Yeah.
circuit.
Yeah, because it's all connected, right?
You break any point, the thing behaves differently already.
Okay, so
Yeah.
the resistor controls the current throughout the entire circuit and not just after it.
Okay,
so
yeah.
Current isn't used up.
Yeah, I mean, current, yeah, how do you use up current? I mean, current is, you use up current. You can reduce current, you can increase current, you can...
Yeah, as in it doesn't
Yeah.
reduce the current afterwards.
Yeah, it has to be the same throughout. In this simple circuit at least. Yeah.
So our physics teachers are right.
Great. All's good with the world.
Yeah, let's
All right. Hope you learned something.
hope you did.
Yeah.